Today we're looking at proving triangle similarity by angle, angle, side, 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 and side, angle, side. These are abbreviated as AA, SSS, and SAS, similarity. Similarity is represented by a little symbol like this. It's kind of like a backwards, sideways S symbol. We're going to establish angle-angle theorem. We're going to prove triangles are similar using angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Our first similarity theorem is angle-angle similarity theorem. If two angles of one triangle are congruent, so we have B is congruent to Y and C is congruent to Z, then the two triangles are similar. So if you have two angles that are similar in a triangle, the two triangles are similar. So this says triangle ABC is similar to triangle XYZ. Our next one is the side-side-side similarity theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. But when you do this, all three sides have to be proportional. So AB divided by XY is going to be equal to BC divided by WZ. And CA is divided by ZX. All three of those proportions will be equal. And whatever they reduce to, that will be the scale factor. Then triangle ABC is going to be similar to triangle XYZ. Now remember, similarity doesn't mean they are exactly the same size and shape. That would be congruent. But all of the angles will be congruent and all of the sides will be proportional. Our side-angle side similarity theorem says if an angle of one triangle is congruent, so right here we have angle A is congruent to angle X, and the lengths of the sides, including those angles, are proportional. So AB divided by XY is going to be equal to AC divided by XZ, then this would be side-angle side similarity. So we would know that these triangles would be similar because they have two sides that are proportional and the angle that's inside those two proportional sides is also congruent. And these two triangles would be similar. So let's go ahead and look and see which one of these similarity theorems we would use. We're trying to figure out if they're similar. So on number one, we have an angle that is similar. So we can use angle-angle similarity, but since there's no other angles, we're not going to use that. We could use side-side-side similarity, but we only have two of the sides. So the only other option is side-angle side similarity theorem. So we know that one angle is similar, but we want to show that the other two sides are proportional. So I'm going to take 49 and 91. Those are both on the first triangle. I'm going to put those in the numerator and set them equal. Now 49 is the smaller of the two side lengths, so it is going to go with 42, which is also the smaller of the side lengths. So 42 is going to go under 49, and since 78 is the bigger of the two, it's going to go under 91. Now I want to see if these are proportional. You can put them in your calculator. 49 divided by 42 is 76. And 91 divided by 78 is also 76. Those are equal, so they are proportional. So this is going to be side-angle side similarity. And the scale factor K is going to be 7/6. It could also be 6/7 if you had to put that the smaller triangle was on top. So if you had to flip those around, it would have given you 6/7. So either one of those proportions could be used for the scale factor. Now I have an angle here. I don't have any of the side lengths, so the only way to do to show that they are similar is by angle similarity. But I have to have two angles of both triangles be the same. Now I'm noticing that we have vertical angles here. So since those are vertical angles, we have two angles of the triangles that are the same. And if two angles of the triangle are the same, the third one automatically has to be because of that third angles theorem. If all three angles add up to 180, and you know two of them, automatically the third one is the same. So you only need to know that two of the angles are the same to tell that all three are the same. So this would just be angle similarity here. Now number 3, I see another set of vertical angles. I also have two side lengths here. So if these are similar, it would be because of side similarity. But we have to just double check. I'm going to take one triangle, 4 and 6. We're going to put those in the numerator. And I'm just going to put a question mark. I'm not really sure if these are similar. 4 is the smaller number. It's going to go with 14 of the second triangle. And the larger number is 21. Now we want to just check to see if these are going to reduce to the same answer. 4 over 14 reduces to 2 over 7. 3 goes into 6 2 times. 3 goes into 21 7 times. So both of those are going to reduce to 2/7. If you can't do that in your head, you're welcome to do it in the calculator. So this would be congruent because of side similarity. Okay, let's look at number 4. We have an angle that's the same, and this is a really similar setup to this last problem, but we need to check to see if the side lengths are equal. So, or are proportional, sorry. So we're going to take one of the triangles. It doesn't matter which one. Let's take 13 and 14. Those are going to go in the numerator. In the denominator, we're going to take our 28 and 25. 25 is the smaller number, so it is going to go under the 13. And 28 is the smaller of, or is the bigger number, so it's going to go under 14. We're going to see if they reduce. 13 over 25 does not reduce. 14 over 28 does. This reduces to 2 goes into 14 7 times. 2 goes into 28 14. This reduces to 1/2. Now 13 over 25 is not equal to 1/2. So these would be not similar triangles, because the fractions did not reduce to the same number here. Now number 5, we have 3 sides. So if these were proportional, it would be because of side similarity. We're going to just take one of the triangles. We have 70, 63, and 98. And we want to see if those are going to all reduce to the same number if I put the second triangle in the denominator. Now 63 is the smallest of the 3 numbers, so it is going to go, 36 is the smallest, so it's going to go under 63. 56 is the biggest, it's going to go under the biggest number of the top fraction, which is 98, and 40 is just kind of in the middle. 70 over 40 reduces to 7 over 4. Now, I think 9 goes into 63 7 times. 9 goes into 36 4 times. So those are equal. Now let's see, 56. I'm wanting it to be a 4. This one, let's just put it in our calculator. 98 divided by 56 is also 7/4. So all 3 of those are going to be 7/4. So this would be proportional because of side similarity. Now, if I have number 6, I have two sides that are the same. That means it's in an isosceles triangle, and in every isosceles triangle, if the 2 sides are the same, the 2 opposite angles are the same. So this would be 70 degrees. So this third angle right here all triangles add up to 180 degrees. So if I take 180 degrees and minus off 70 and 70, that's minusing off 140, which is just would leave 40 degrees for this last triangle. Now, if I look at the bottom triangle, I only have one angle. It's 30 degrees, which is not equivalent to any of the angles here. So these two triangles would not be similar because the angles do not line up. Okay, now 7 and 8 are very similar to questions on your homework. We're going to determine what information you can derive from the images. Determine whether the pair of triangles are similar. If they're similar, write a similarity statement. If the pairs are not similar, we're going to write does not exist, DNE. Let's write does not exist in the similarity statement. So first thing we want to know, is F and C congruent? From the picture, it does not have any markings to say that F and C are congruent, so we are not going to check that box. Likewise, in the same argument, G and D it doesn't show that G and D are congruent, so we're not going to check the box. But we do have three sides, so this would be side, side, side similarity if they are similar. So we're going to make some fractions here. Notice that they have the smaller triangle is in the numerator. So I'm going to put all of the smaller triangle numbers on top, 56, 40, and 36. And then we're going to put the corresponding triangle with it in the right order. So the biggest number is 98. It's going to go under the biggest number here of 56. The smallest number is 63. That's going to go under 36. And 40 is going to go under 70. So 40 over 70 reduces to 4/7. So that is a true statement. I'm going to just check that box on the homework assignment. 36 over 63 reduces to 4/7. That's a true statement. I'm going to check that. And 56 over 98 is a true statement. So all three sides are proportional. The triangles are similar by side, side, side similarity. So I would only check the boxes that I can tell are true from the picture. Now, A and E. If I'm looking at A, that is a 90-degree angle, and E is a 90-degree angle. So from the picture, I can tell that those two angles are congruent. So I'm going to check that box. Now, if I take 90 degrees here, and I take 180, and I minus 90, and I minus 13, that will give me angle C. And angle C is 77 degrees, so C is not congruent to D. D is 75. So I'm going to check this box because I can tell that is true from the picture. Angle F, we have 180 degrees for this triangle, and I'm minus 90 and minus 75. If I minus 90 and minus 75, I get 15 degrees. So F could not be congruent to B. So that is true. So I'm going to check all three of these boxes. So BC is similar to DF. Now you can't show that lines are similar. That's kind of a nonsensical statement. You can say that triangles are similar. So we are not going to check that BC and DF are similar, so don't check that box. Two corresponding angles are congruent. We do not have two corresponding angles that are congruent, so we are not checking that box. The triangles are not similar. We're going to check that one because they are not. None of the angles line up. So we're going to say the triangles are not similar by, we're going to put DNE for does not exist. And we're also going to put D and E on the triangles because that doesn't work. They are not similar. So if it doesn't make sense, put D and E does not exist. So sometimes you have an example where there is not a picture. So what we're going to do is we're just going to draw two triangles. We're going to label these ABC and XYZ. A is going to be 23 degrees. B is going to be 69 degrees. X is going to be 23 degrees. Z is going to be 88 degrees. So we need to have two angles that are the same for these to be similar. So we're going to say, is ABC similar to XYZ? So if I take 180 degrees and I'm minus 69 and 23, I get 88 degrees here. And so that shows me that two angles are congruent. And so, yes, these triangles have to be congruent by angle-angle similarity. And we're going to find the value of x, number 10, that makes RST similar to HGK. So RS has to be proportional to HG, RS and HG. So 3 and 5 are from this triangle here. And on the other triangle, we have RS goes with GH. So under the 3, we're going to put an x plus 7. We want to put this corresponding side. So ST has to go with GK. So under 5, we're going to put 20 over 3. Now we're going to cross multiply these. 3 times 20 over 3 is going to equal 5 times x plus 7. 3 times 20 over 3 is 20. We have 5x plus 35. Minus 35 from both sides. Divide by 5. And so x has to equal a negative 3. So if this x is negative 3, we would put a negative 3 in for x, and this side would be a 4. On this next example, we're going to verify that triangle RST is similar to triangle XYZ. So we're going to find the scale factor of RST to XYZ. Okay, so let's go ahead and write all of the RST triangle sides on the top, 12, 15, and 24. Notice they are in order from smallest to largest. And so we're just trying to verify. So it's saying that pretty much that they are. We're just showing that they are. That when we put the next triangle numbers underneath, they should all reduce to the same number. And whatever number that is, that's going to be our scale factor. So let's go ahead, make sure you put the smallest under the smallest. So 28 is next, then 35, and then 56. 12 over 28 reduces to 6 over 14, which reduces to 3 over 7. 15 over 35 also, let's see here, 5 will go into both 15 and 35. 5 goes into 15 3 times. 5 goes into 35 7 times. 8 goes into both 24 and 56. 8 goes into 24 3 times, and 7 times 8 is 56. So all three of those reduce to 3/7. So that would be our scale factor. Now we could have 3/7, but if we had have switched all of these numbers around, so all the numerators were all the denominators were in the numerator and all the numerators were in the denominator, we would have gotten 7 over 3. So either one of those could be considered the scale factor. Now we have this is a story problem. There's a man and he is 6 feet tall. When you have a story problem, it's really helpful if you want to just draw a picture. He's 6 feet tall, standing next to a building. The man casts a 9.5 foot shadow. We don't know how tall the building is, but we know that the building casts a 190-foot shadow. So we want to know how tall the building is. Now the sun is going to be up here, and it's kind of casting the same angles, and so the angles are going to be same, so the sides are going to be proportional. So we're going to just take this man, and we're going to put these numbers in the numerator, 6 and 9.5. And the 9.5 is the bigger number, that's the shadow number. So 190 is going to go with the 9.5. Those are the shadow numbers. And then the building, we want to know how tall that building is, so we're just going to put X. We're going to cross multiply 190 times 6. So 1,140 is going to equal to 9.5x. So we divide both sides by 9.5. And so x is going to be 120 feet tall. So that's how the size of the building is, 120 feet.